We're going to get started with our data analysis and data representations unit by looking specifically at histograms. Now, histograms look very similar to a bar graph, but it turns out that they are not bar graphs. They are very specific in that they represent what is referred to as numerical data. Bar graphs represent what is referred to as categorical data. So those will be things like names, favorite colors, things of that nature, whereas numerical data doesn't represent words, it instead represents numbers. So things like your height, your age, the number of days until some type of isotope decays, something of that nature. So let's go ahead and take a look at these histograms now. All right, to get started, we're going to be looking at some model data. This is tomato plant data. In other words, all of these numbers in the data table represent the number of days it takes for different tomato plants to produce tomatoes. We're going to use this information to complete what is referred to as a frequency table. So before we get started building our histogram, basically what we want to do is organize our data. We're going to take all of these individual data points and we're going to tally them up into the frequency table so we can see how many data points in each of the intervals we have. When I say intervals, what I'm referring to is the group from 41 to 50, or the group from 51 to 60, or from 61 to 70, and so on. Each of these categories or groupings is referred to as an interval. All right, so I'm going to take a moment and tally up the data, and then we'll get right back to building our histogram. All right, now that I've tallied up the data, I've also created some counts of that data just so I can see up close how many data points I have in each of the intervals. All right, and I brought that data next door and I shrunk it down so I have some space to build a histogram for you. Now, you can do this on your paper using a straight edge or a ruler, or you can just watch along and see how it's done. All right, there we have it. It's certainly not perfect, and that's okay. I want to point out a couple of different features, though, of this histogram that are different from a bar graph. For one thing, we don't refer to these specific groupings as bars as we would in a bar graph. Instead, they're referred to as bins. So this would be bin 1, this would be bin 2, and so on. Secondly, the width of a specific bin is referred to as an interval. We'll notice that with a histogram, the interval width is constant over the course of the entire histogram. So each of these intervals has the same width. We notice that each of our bins are adjacent to one another and they touch. This is because we are not skipping any numbers. We go directly from 50 to 51, from 60 to 61, and so on. Since we're representing numerical data, there's no space in this particular histogram to represent decimal numbers. Now, that's specific to this histogram. You could build one that does include decimals, but this one only includes integers, so we've only got those whole numbers, 50, 51, 60. That's because we're representing days, and we're not accounting for parts of days in this particular graph. All right, now realistically, we do not build histograms by hand in this class. We did that back in 6th grade. However, you do need to be able to read and interpret a histogram. For one thing, let's talk about the shape of this histogram. If I were to draw a curved line over the top of the bins of these intervals, we would notice that we have approximately a bell shape. However, of course, we can see in the 91 to 100 category, there's a big drop off in the data. So it's definitely not symmetrical. It's more skewed in that regard. We can see that the majority of the plants produced fruit between 60 and 80 days, and that there were some plants that produced fruit between the 40 and the 60-day interval. So it gives us a little idea of the shape of the graph and what a typical value in the data set might look like, or where it might lie on the histogram. We're going to look now at how to build a histogram using technology. Specifically, we're going to use Desmos to do this. We're going to use the exact same data set that we were using before and create a histogram with intervals of width 10 once again. So previously we used the interval widths 41 to 50 and 51 to 60, which included those endpoints. We're going to use Desmos to do the very same thing. However, we're going to take advantage of the fact that we can easily make adjustments using technology, and we will adjust those interval widths down to a minimum of 1 day up to a maximum of 20 days. And when we do this, we're going to be able to see how the interval width itself affects the shape of the histogram. To access a pre-built histogram, you can use the link in the description of this video, or you can use the QR code that is on your paper or here on the screen. Once you have the Desmos worksheet open, we'll look at how to get that data into Desmos to get started. You can type a capital L followed by an equal sign, then open a square bracket. From here, you're just going to type all of your data points in individually. They do not have to be in numerical order or organized in any way. All you'll do is type each data point followed by a comma. So 47, 60, 65, and so on. When you're done typing your data, use a square bracket on the right-hand side. Now, if we look back to our original data set, we had 6 rows and 5 columns, which makes 30 data points. 6 times 5 is 30. And you'll notice that Desmos counts up the number of items in your set. So we do, in fact, have all 30 items in our data set here. Next, I'm going to click on the icon next to the first folder that says Open to View Histogram. When I click on the icon, it reveals all of the contents of that folder. I can also use the arrow to drop down and open the folder itself to see what's inside. To ask Desmos to build a histogram, you are literally going to type the word histogram, followed by an open parentheses. Then inside those parentheses, you'll type that uppercase L, which references the data set that we just typed in, followed by a comma, and then you'll list the width of the interval or the bin that you would like to use. Since we used an interval width of 10 on our paper, we'll start out by using 10 on Desmos as well. From here, you can tap on the Zoom Fit option, which will center the data so that you can view it on your screen or on your device easily. The first thing that we'll notice is that our histogram on Desmos looks very similar to what we built on paper. I'm going to adjust the view just a little bit more here. Before we make any adjustments to the interval width, I want to point out something that you may have noticed on your screen. If we look really carefully at the interval widths on Desmos, you'll notice that they don't exactly match what we had on paper. For example, if I zoom in really closely here, I can see that my interval widths are indeed 10, however it ranges from 45 to 55, not from 41 to 50. This difference is due to the way that calculators in statistical software determine where to place the intervals itself. What the software will do is take a look at the actual data set, determine the minimum and the maximum value, and then draw intervals around that range. If we were to look back at our original data, recall that our first interval, 41 to 50, only had a single data point in it. Our last interval, 91 to 100, had no data in it. Desmos and other software like it is going to attempt to reduce that discrepancy. In other words, it does not want to draw empty bins if possible. So instead, it will attempt to center the intervals around the actual data set. Nonetheless, we can make adjustments as much as we want to. So I'm going to take this bin width and just type over the 10 and change it to, say, 5. When I do this, of course, I create additional bins with smaller intervals, and I dramatically change the shape of the distribution. If I take this down further still to say 1, I've converted it basically into a dot plot. In other words, each of these intervals represents just a single day, and the height represents the frequency. I'm going to bring this back up to 10, and then increase it further still to say 15. After adjusting the height, I can see that I've reduced the number of intervals and the number of bins, and I've lost some of the shape of the distribution. If I increase this back up to say 20, I've completely lost the shape of the distribution, and now I'm only able to tell that the majority of the plants produced fruit between these particular endpoints. It looks like it's about 50 days and 90 days. I'll reset this back to 10, and once again I can see that the most frequent interval actually occurred in looks like 75 to 85 days. Now, to answer that final question, how does the interval width change the shape of the histogram? Well, we saw that decreasing the interval width shows more individual data points, but unfortunately that masks the behavior of the group. We're not able really to speak on what the group trends are when we've reduced the intervals so small. On the flip side, if we increase the interval width, we're able to show those group trends, but unfortunately the resolution or the detail is lost. We're not able to say, for example, that the majority of the plants produce fruit between 75 and 85 days. That statement would have to be expanded out to, say, 55 to 90 days instead. This wraps up our discussion of data representations. In our next videos, we're going to look at how to build a box plot as well as how to build a 5-number summary using both Desmos and paper pencil.